Okay, in this lesson we'll be looking at determining equations of polynomial functions, either given a graph or some sort of written description. So let's take a look at this first graph. So how are we going to figure out the equation of the polynomial function? The key thing is typically we're going to write the equation in factored form, and we can determine those factors by using the x-intercepts of our graph, because the x-intercepts, well, they are the factors. So if we take a look at our graph, we can see that we have x-intercepts. We have an x-intercept of -3, 0, and 2. So let's just write those down. So -3, 0, and 2. What we can also determine, though, is the order of these x-intercepts based on the shape. So you can tell that, like, the first one at -3 is order 2 because it's a turning point. It looks like a parabola there. The next one at 0 is order 1 because it just goes straight through. No fancy behavior going there. And the third one at x equal to 2 is order 3 because it has kind of that cubic, the flattening shape there. And so we can include that in our information here. Order 2, order 1, and order 3. Okay. That's going to allow us to basically create almost the full function. So we can begin creating it. F of x equal to x plus 3. And the order will tell us what the exponent is on that, squared. We have x. I'll write it as x minus 0. Typically, we would just write it as x. And the exponent 1, which typically you also don't need to write. And then x minus 2 to the exponent 3. The one thing we don't have is there might be some lead coefficient. Maybe it's like 10 times everything. It might be a negative. Who knows? But there could be some sort of lead coefficient. So that's the goal, is we need to figure out what this lead coefficient is. To figure that out, we just need to pick any other point on this graph. And there might be multiple points to choose from. I'm just going to look at this graph and I'm going to choose, this point, kind of near that one local maximum. That looks like the point -2, 4. And so let's sub that in. So f of -2 is going to be equal to 4. We know that. And f of -2 is going to be a times -2 plus 3 squared. -2 minus 0 doesn't matter. To the 1 doesn't matter. -2 minus 2 cubed. We know that is equal to 4. So I'm replacing the f of -2 on the left with the 4. And let's just simplify the right. We're going to get 1 squared. Well, that's just going to disappear. -2 and -4 cubed. Okay. So combining everything on the right, -2 times -4 cubed. So the 4 cubed will end up being something big. 64. Doubling that is 128. We have a couple negatives, so it ends up being positive, which is what we want. Because if you look at the end behavior, we're going up to positive infinity in the top right quadrant. So you need a positive lead coefficient. And solving for a, dividing the 4 by 128, we're going to have a fraction, which we can reduce. So make sure to reduce your fractions if possible. That will mean a is equal to, and essentially the 128 will actually be able to divide by 4. We could have actually left it as 4 cubed. 4 over 4 cubed, the 4's cancel out. And this will become 1 over 32. So therefore, f of x, we figured out that lead coefficient is 1/32. And the x minus 0, I'm just going to write that as an x in front. Typically, if it's just an x, just leave it in front. And then the rest I usually just do then in order from least to greatest factor. So x plus 3 squared, x minus 2 cubed. And there we have it. There is your equation of that polynomial function. So really, we're using the x-intercepts, their orders, and some other point, and that's all you actually need. And yes, the key thing is you need to get those orders of each root correct. If you mess them up, well, then you're not even going to get the correct equation, because that will then also lead to mistakes with your lead coefficient. All right, let's continue on. So we're going to skip that whiteboard time. But yeah, so in general steps for creating an equation: determine the roots, determine the order of each root, set up your factored form, and then substitute in a point to get that lead coefficient. If you can do those 3 steps, you can find out the equation of a polynomial for the most part. Sometimes there may be trickier situations, but that is a general structure that we can make use of. Okay, let's do this one. Try it out yourself first, and I'll go through it right now too, but don't hesitate to pause the video just to try it out. Okay, so first, let's identify the x-intercepts. So the x-intercepts are x equal to, looks like we have -3, -2, and 1. So I'm going to write that down, -3, -2, and 1. I'm going to get the orders of each. So when you're looking at the order, you have to pay attention to what is happening at exactly the root, not necessarily around it. So even though it goes kind of up around it, that's fine. But at exactly -3, we're just going through the x-axis. So that is order 1. And at -2, it's coming from below, hitting -2, and going back down, which is like a parabola. So it's order 2. And at 1, just going straight through, so order 1. Okay, so we've got those 3 roots and their orders. So now, based off the roots and their orders, set up your general equation. So again, the general equation will have some parameter in front. We're just going to call it a. And then the root. So x plus 3 to the power of 1. X plus 2 to the power of 2, since it's order 2. And then x minus 1. So there we have it. That is the general equation. And I could even say for some a an element of the real numbers. We don't know what it is. That's what we're trying to figure out. So let's find a point that we can make use of. And in this case, and oftentimes is a good point to use, the y-intercept, which is the point 0, -4. So f of 0 and just to note, that means f of 0 is equal to -4. So let's plug that in. F of 0 is a. You can just drop the x's because they're 0. 3 times 2 squared times -1. Well, we know that what that is equal to, that is equal to -4. 3 times 2 squared is 3 times 4, 12. So it's actually going to be -12a. And just divide by -12, so a is equal to -4 over -12, and make sure to reduce and simplify. That's the same as 1/3. So therefore f of x is equal to 1/3 x plus 3, x plus 2 squared, x minus 1. And yeah, we can kind of at least confirm that a little bit, just in terms of the sign. 1/3 is positive, and if we look at our end behavior, especially as we go to the right, we're going up to positive infinity, which matches that. Okay, now let's take a look at a situation where, a couple situations where we have just, in a sense, we can call them word problems, where we're given information in words and we're trying to find the equation. So we have an equation with end behavior as f of x goes to -infinity, whether you're going to positive infinity for x or -infinity. So basically, we're going down as we go to the left or the right. So that's the same as saying quadrant 3 to quadrant 4. Okay, so that tells us a little bit. We'll see how we make use of that. And we also have a 0 at x equals to 5. So let's note that. And that's turning point. So remember, turning point is a local maximum or minimum. That will actually tell us order 2. And we have another 0 at x equal to 2. And it says it's a point of inflection. In this case, a point of inflection, you'll see more of it in calculus. For our purposes, we're going to identify as kind of where the graph flattens. In reality, when we look at points of inflections in calculus, we'll see that's not necessarily always the case, but for our purposes here, that's what we're going to take it as. And so that's going to be order 3 then, since it's doing that flattening shape. And we have a 0 at x equal to 1. Okay. So let's put down those zeros, or the x-intercept. So let's start with that. And we have x equal to 5, x equal to -2, x equal to 1, order 2, order 3. And the question is, do we know anything about the order at x equal to 1? It might seem like we know nothing about it, but we can actually use a little bit of information. Because what we know is the end behavior is quadrant 3 to quadrant 4. And that only happens for even degree. That's going to be a key thing. So if our end behavior is telling us that we have even degree, well, the orders have to add up even number. So choose order 1. And then that will mean degree equals 6 then. You could choose something like order 3. Really, it just has to be some sort of odd number so that when you add up those 3 things, you get an even degree in the end. Okay, what does the question actually ask for? It wants the general equation. So we want f of x equal to a x minus, well, here, I'll go in order from least to greatest, x plus 2 to the power of 3, x minus 1, I said order 1, x minus 5 to the power of 2 for an element of the real numbers. So that is the general equation, because we don't have any sort of actual point on this function that we can use to figure out what the lead coefficient is. All we know is that a is some real number, and not only that, by the end behavior, since we're going down to negative infinity, a must be less than 0, because we need a negative lead coefficient. Okay, so let's look at that situation there. Let's take a look at this last one. Let's determine the equation of a cubic function, so keep in mind what the degree of a cubic is. Degree 3. With roots x equal to 1, x equal to -3, and some other root. Okay, so we have 3 roots there, and we have a cubic of degree 3, so that actually tells us that all the roots are order 1. Since it's a cubic function with 3 roots. Okay, and we have a y-intercept of y equal to 45. And we go through the point to -45. Okay, so let's get down some of this information. So let's get down our x-intercepts, as we have in the past. We will get down x equal to -3, x equal to 1, and we have some mystery root. I'm just going to call that r. R for root. Who knows what it is, but we know that they're all order 1. So if we write down our general equation, what we'll have is we'll have some sort of lead coefficient, a, x plus 3, x minus 1, and then x minus r. So we actually have two unknowns here. But the good thing is we have multiple pieces of information we haven't used yet. We can figure this out. So I'll just say a and r are elements of the real numbers. We'll determine specifically what they are. So let's substitute in both our y-intercept and the point 45. So we will have here the y-intercept, y equal to 45, which means f of 0 is equal to a times 3, -1, and then we have negative r. So we have 45 is equal to 3 times 1 is 3, and then you have the two negatives, which will become positive, so it's 3ar. Or divide by 3, 15 equals a times r. I'm just going to leave it like that. We might do a little bit more with that, but for now, we'll work with it in this stage. Okay, the other equation, the point to -45, is going to become f of 2, is going to be, this is where things will get a little tricky because we'll have an a here, we'll have numbers being added, 2 plus 3, we will also have 2 minus 1, and then 2 minus r. It's not the nicest looking, and that's going to be -45 because that's where the y value is of the point. But yeah, we just need to simplify the right hand side. So we get 5, 1, 2 minus r. I'm just going to keep simplifying that for now. And what I'll do in this case is we could expand it. Yeah, let's expand it. There are a couple different ways you could tackle this, but you have two equations, two unknowns. So we're going to do kind of some form of substitution. Elimination might be a little bit trickier just because we have multiplication going on between these variables. It's not just like x plus y, but there's multiplication, a times r. So that does make this a little trickier, but that's okay. Okay, so I've just expanded that, and what I'm going to do is, well, we have a times r on this left equation, and we have a times r here. So sub in ar equal to 15. And so that will just become -45 equal to 10a minus 5 times 15. Okay, and now we just have an equation in terms of a. We can solve for a, we can solve for r afterwards. So then we can get our final function. So -45 is equal to 10a, 5 times 15 is going to be 75. Add that to the other side, is going to be 30 equals to 10a. Divide by 10, 30 divided by 10 is 3. So a is equal to 3. There's kind of the first answer we want. And now we can sub in a equals to 3 into 15 equal to ar. And so 15 is equal to 3 times r. We'll divide by 3, and so r must be 5. Okay, and so that leads us to our equation. Therefore, f of x is equal to, going back to the original equation, a was 3, so sub that in at the start, x plus 3, x minus 1, and then x minus 5. So the final root is 5. And there we go. So that's a trickier situation where we had to solve for actually the equation and one of the missing roots by plugging in multiple points. But there we have it. So that is a look at determining equations of polynomial functions.